I think we're on now, so hello and welcome to another stream. We're going to be doing some more PortAudio programming today. So let's get into it. Let me first of all, start up the project. And again, I'm using Windows for now. And let's open the Visual Studio Code project, or the CMake project actually. One second, I'm just turning off the tablet here on the side. How's everyone doing? I hope you're all well. I mean, if anyone's watching this. And I also want to see if I can put a chat up here. Right, docs, chat, there you go. So yeah, for people who are watching this in the future, we're going to be basically cleaning up the code that we've written in the past 2 days or so. And as a summary, what I did is I basically included a bit of atomic flag in the stream data struct, so that we can know whether or not the audio stream or the audio queue has been read from, and therefore if there is space to be written to in the future. And at the moment, the main program does block until there is space in the queue. So basically, this flag here dictates exactly just that. Actually, this is a good place to start. So I have this struct here called PA stream data, right? And the main place it's used in right now is in the main function, and also in the audio callback that we've got. Let's take a look at that. Let's see. I think it's PA stream data. There you go. So this is basically where it's used here. And I know for a fact that we're no longer using some of these fields anymore, because they were here from the PortAudio example, right? So if we take a look at it, I believe we're no longer using the left and right phase, nor are we using this step. Oh, I reconnected, so hello. Yeah, so I'm not sure how much of that we saw, but I removed some of the fields in the struct that I wasn't really using. So all that's left here right now is the left and right audio cues for each of the channels, and also the multiplier for the volume and the atomic saying whether or not it's ready. Okay, now let me check something here online really quickly. And I've got a hot chocolate with me today, so that's going to keep me awake. I also need to keep the chat up here so I can actually see it. I'm just reading about how to properly back a struct, because I can't remember whether you should do not that it matters too much in here, but a good practice is to always back your struct properly in terms of, I can't remember now if it's like the smallest elements first and then the biggest elements after, because C++ will basically align your data types of the struct on it depends on the machine really, but usually on 4-byte or byte boundaries essentially. So I'm trying to see, yeah, I think it's 4-byte boundaries in my particular case. Not that it matters too much, because this struct has actually not been used in anything that's like sort of performance, like that should be very performant in the way that we'll be copying it and whatever. No, it's only been used to refer to from the audio queue and the main thread, so it doesn't matter too much. But that's something interesting that I just wanted to look at, basically. Oh no. I am getting some spam, I guess, on the chat, which is interesting. I don't know how to remove comments, really. I definitely don't want anyone spamming their shitty streams here. There you go, remove. There you go. All we can do is simply just report these, I guess. Yeah, it seems like it's the largest to smallest element, I think. And I believe that's what it is. And if you're interested in knowing why you have to pack your struct properly, I mean, you can read about it here, but it's basically to do with the memory layout of things when it gets compiled down and how efficient your struct is going to be. And that can really affect performance sometimes if you're doing a lot of copies and moving of things, I guess. Which is not our case, but I just still want to do it properly anyway. Right. But yeah. Cool. So biggest to smallest. I believe this is probably the biggest. Yeah, these queues are probably the biggest, right? And then after that, I think we have an atomic and definitely the float, right? So what's the size of the atomic actually? That's something I don't know. Size of atomic or float. I don't actually know what the size of atomic is. Atomic size T. Oh, that's the one now. I mean, it is something I can just do on Compiler Explorer really quickly. Let's test it out. I'm just gonna find out what the size of the atomic is, because I have no idea. And if I just do a std, yeah, you know, size of atomic. Of course, let's include the IO stream header so we can actually print it. And atomic is already there, so the size of atomic is actually 4. Oh, interesting. So what's the size? Yeah, they're both the same size. Interesting. I didn't know that. How come though? The size of atomic and the size of flow are the same. So, yep. That's interesting to know. I'm trying to finish my hot chocolate. Yeah. It's actually really good. We're nearly over now, I promise. And here we are. So let me just check one of the emails I got really quickly. Yes, sorry about that. Okay, cool. Sorry, I'm gonna take another 2 seconds here. Sorry, just writing a message, and I'll be back in a second. I'm back now, so let's crack on with this. Right, so another thing that would be cool is just to rename this, because like we're trying to get away from the PortAudio stuff, right? So PA is kind of a name that you get in the PortAudio struct, so let's just remove that for now and call it just audio data. Audio data, I don't like that really. So audio queue, really, something like that. And then if we obviously try and build in and see where it's going to fail, so we can replace all the names. We could have just used the replace functionality really. Use definition of that. I don't give a damn about this. There you go. this is audio you there. Right? And what else have we fucked up on? Oops, sorry. What else have we messed up on? Yeah, so the audio cue. And there was another one as well. Stream. Audio cue there. And then obviously this one, I guess. Okay. Audio cue. Try and build again. It should build now. Maybe not. Look at the first error PL stream undeclared identifier. Okay. See, the best thing to do in C++ when you're modifying something is to just compile it and see if it's going to build. Because quite clearly, you know, if it doesn't work, then the compiler couldn't parse it, which means there's something wrong in your code, and it'll tell you exactly where it is. Okay, did that mess up? My Vim kind of just crashed there for a second. Okay, another one. Why isn't this telling me what all of the instances of PA stream data is? Okay, we've got a warning that we can fix later. Okay, so now we finished. Cool. So I just made some minor refactors, I guess. Let's actually check out to main. Huh? I think I already merged this, but just create a refactoring one. Okay, cool, here we are. I'm gonna also turn it off so you guys can see what I'm typing here. Cool. Yeah, so ideally, let's look at the main and look at the logic here. So what is this? Conversion from float to atomic or bool requires an iron conversion. Okay, so this is clearly wrong because it should be ready and then this, right? The volume multiplier, that's what it is. So although it compiled, the warning kind of helped us there, which is good. Very, very good indeed. That's another thing as well. Let's turn up all of the warnings to error, shall we? So what's the best way of doing that in CMake? CMake enable warning errors. So I can't, you know, you can obviously do it as per compiler, on a compiler basis. Because, you know, each compiler has different flags, but I was wondering if there's a good way to do it in CMake. This might do for now. I think this might do for now. Yeah, see, this will do it for every target that we have, which is cool. We can definitely do that. I just want to globally set the tags. I know this person is saying not to do it because it should really work on a target basis in modern CMake, but in this particular case I think it would cause no harm really. Including a compiler check. Ooh. Let's read this guy's tutorial and see if it's actually useful. My previous approach, yeah, I mean this is usually how I used to do it before as well, just set the CMake CXX flags. And ideally we're gonna put all of these available extra warning error flags. So oh yeah, I came across this website before. This guy's really good, Jonathan. Yeah, he's really good. I tried to, I think I connected with him. Yeah, there you go. So he has really good CMake tutorials and CMake, or just C++ and CMake posts as well. So yeah, I do like this. I mean, yeah, let's go with a mixture of what this guy's doing and all the flags that we had previously as well in the Stack Overflow answer. So these are the ones we want to do for obviously Windows, and these are the ones we want to do for yeah, so let's do a little bit differently, right? So my CMake lists, what I'm gonna do is I'm gonna put that down here. So instead of this, I'm gonna set the I'm gonna set a variable called one flag or something, and that will be obviously, you know, in this particular case it will be W4 WX for Microsoft. And let's take a look at what these actually do. I know that W4 has, you know, quite a lot to it. It's not just one sort of set of warnings. I think of the highest level of warnings actually. So W4 it specifies level of warnings generated by the compiler 0 to 4. So W4 displays level 1, level 2, and level 3 warnings. Okay. So maybe we actually want this. Warnings that are off by default. Compiler warnings that are off by default. I want to know the actual warnings though that we have. Yeah. I guess it's like a really long list somewhere, right? Yeah, there you go. All of the warnings and see. Yeah, I'm not gonna read all of them. But I think I'm gonna do W4 for now. Yeah. What's WX as well? Let's take a look at MSVC. It's all compiler warnings has errors, right? So this is W error kind of equivalent. Okay. Cool. And same thing here. We're gonna set the one flags here. It'd be all of this shit here. So some of them, well, really all of them are good to have. So WO is going to show all the warnings. Not actually all the warnings. It does sort of keep some of the warnings turned off by default. I think something like the sign stuff. Signers of an integer will doesn't match us, so still not give you an error. W extra, W error is going to show warnings that are errors. Pedantic and extra are just extra warnings. Should leave us this for now, and then we see if we need the extra set of warnings that these don't include. And obviously, every time we go into a target that we want to build with the warnings, such as the audio demo, we're going to actually add the compiler options there. So kind of like target compile options or definitions, is that right? No, compiler options, there you go. And then we've got audio demo, private, and then we do the warn errors, I think it is, right? That's what I said, warn flags, there you go. Let's see if it's gonna work. Man, I hate these things on the bottom of Visual Studio. What's the error here? Excuse me. Target compile definition is called with incorrect number of arguments. Yeah, it's not target compile definition though, is it? And yeah, we're gonna do the same thing for the audio library. So let's do that. So target file options, and we've got audio here, private, and then we've got the warn flags there. And I can see if this is working by actually kind of displaying the CMake verbos, I think it is, where it shows me all the compiling commands, essentially. My computer's very slow now for some reason. Let me turn some of the stuff off here. Okay. Ooh. Not that Discord is gonna change much, but I mean, this definitely works for the make files. Does it work for Visual Studio generated project as well? So we're about to find out. Let's put it into workspace settings. I have no idea where this came from, but oh well. Okay, let's regenerate everything now. Deleting the cache and reconfiguring. Just basically trying to show the compilation commands once we actually hit the compile button. I'm hoping that will actually display it so we can see whether or not the extra flags that we've added are actually working. So alright dude, so let's hit this. There you go, it's actually verbos, so we can, is it verbos? Creating, there you go, it is. Right, so let's figure out whether or not, I mean, holding CL here, which is the Visual Studio compiler. On the audio include, and that is an include directory, cool. I am looking for W all, you know, one of those. There you go, W4, WX. So seems to be working. Seems to be working. And it did fail. Now let's see why it failed, because we can now delete this. Really, we don't need all the verbosity. Wonder if there should be a string or a list, you know? Like, let's just do it like this. I think this should work. No, this should work. Let's see. There you go. It's not gonna work. I wish VC Package just realized that it's built whatever it's building now many times before and not had to detect the triplet configuration or the cross compilation configuration here for my build every time. Okay, let's build it now. I mean, it's still verbose for some odd reason. Did I not save the file? I mean, I'm not gonna bother, but you know. Let's figure out what the first error is. The only issue with the Microsoft compilers and MSVC is that it's really long to figure out what the error is. There you go, command line, invalid argument. Okay, so yeah, there is an invalid argument here. Yeah, because these are strings, and it's not really passing them as a kind of list, is it? I will fix that in a second. Let me just figure something out. That still runs. It's just this that doesn't, isn't it? Ah, why is it running? Okay, so let's try again. Build it. What's the first error? Again, invalid numeric argument. And that is because if we look at the actual compilation of something, like the audio, how is it passing the W4 argument? That's my question. The external. There you go, it's just passing it like this essentially, which is not what we want. We want it without the quotes. I think CMake is passing that. I wonder what if we do it as a list. Oh. maybe that will fix it. I'm just taking a look online to see if anything comes up. What if I just do this for now? Does one work? Like, what the hell? There you go. I mean, it goes through now. And it should fail. No, it didn't fail. Why did it not fail? Because I didn't include, yeah, WX as it. But if we take a look at one of the compilations here, like the audio again, we can see where is the W4 been included at. One flags W4. There you go, it is here. External W4. Huh. Right? That's not right, is it? What's external? I have no idea. Let's see. You know, I'm fairly not used to Microsoft compilers, so I'm learning a lot here. Bear with me. External compiler options let you specify compiler diagnostic behavior for certain header files. External headers. Okay, so that's, you know, our W4 doesn't come from there. Where is our W4? It is here. I mean, I can see it there. And it gives me all the, you know, the new warnings, so I know that it is being applied somehow. But I don't see them as errors if I were to do something like this. WX. Oops. I mean, if I see an error, build succeeded. No, it didn't. It's impossible that I don't have any warnings. Let's see, W4, where are we? W4 is here, WX is here. And then we got CL here. W4 and WX, they are being added. What's WX minus? Why is there a minus there? Does it mean like the opposite when it's a minus? Causes no output file to be generated if the linker generates warnings. This option is similar to the verse for the compiler. This only applies to the compiler if you only use it in the compilation step, which is fine. Why are these showing up? Let's see, hello. This will fail, but I want to see where it appears. I want to see where hello there appears in the compilation string. I'm not entirely sure that this is working. That's what I'm saying. One flags. So for example, one flags here. And we've got one flags here as well. So it's not a typo either. Now let's build it. Should have definitely failed now. Good. So take a look here. So I'm looking for hello there. There you go. It shows up here. It's here. So it is actually displayed, which means that this W4 and WX are actually coming from, I guess, our target compile options, which, you know, it's fine. That's what I was trying to check, whether or not this is coming from our settings. It must be, because this is always also been added here. But then the question is, why is it not failing when I've actually got many warnings? That's the interesting thing. This is what I want, you know, similar to W error. Some is kind of shit. So see, warnings, but then it still compiles. Oh no, it doesn't. Why? What's the first error? It should say something like, you know, this warning is being treated as an error. I think that's the default. There you go, error C2220. The following warning is treated as an error. Finally, for some reason, only now it's failing when we have warnings, which is good. That's what I want. I want to show all the warnings so I can go and fix them with proper C++. So, of course, we're gonna have an issue here, aren't we? With the redefinition of this. Macro redefinition. So previous definition of this was here in audio CPP. But why? Audio H. And I do have an if and def there, so we shouldn't include it twice. Cool. Let's see where it's complaining. So tweak me. Sample rate, there you go. We'll get to those warnings in a bit, but this has been not referenced in any way, so. Oh, this is a function that we actually created, right? So what can we do here? Yeah, so end of output channels, that should be this. And then sample rate, this should be, you know, sample rate. End of input channels. Because we have nothing. And now we should compile again. And hopefully those two warnings will disappear. I do understand why some people hate programming in C++ now. I mean, these Microsoft compiling errors are just too much sometimes. Okay, so let's take a look at the first error that we can spot. Okay, so we can, I didn't know that. Okay, this is being treated macro redefinition. But where is the first definition? I will take to those in a bit. We'll be there in a second. So this is coming from SPD log, right? Is this header not including pragma once? It does say pragma once there. I was wondering if it hasn't include guard. No instance of overloaded matches the specified type. Okay, so like why? Alright, let's have a look at the header. So where is the header? So we've got audio, and we're looking at the stream. It takes audio cue and a callback. It takes an audio cue and a callback. This must be an error because of one of these, probably. I mean, they encourage you to comment this out if you're using the FMT library yourself, but I don't want to modify this file because this is in a third-party dependency directory, so I don't want to do that. Right, this is, they literally just pasted FMT here. Huh. Wait, so am I building FMT twice? Of course I am. No, we're gonna uncomment this. We're uncomment to use your own line of the your own copy of the FMT library instead of SVM's copy. Okay, cool. Yeah, this is what we need. Yeah, this is definitely what we need. But where is it being redefined? That's the question. Macro redefinition. Maybe the actual message will show us. Can we just do a global search for this? Where is it being defined? Like, this is the only place it's defined in. What's tweak me? Comes from SDP log, and that is definitely included in the audio code. SPD log. Where else? Where else is it being included? Well, definitely in the main file, I guess, as well, right? SPD log. No? Saying that the other is here and then the other one is here. Like, where? It must be coming from this include. But this is a CPP file and it shouldn't be built more than once. So not even like it's a header and it's been included somewhere that doesn't have a guard on it or something. Audio.cpp, right? Yeah, and it comes from this library here. Audio CPP. And target link libraries are, and then public. Okay, cool. Yeah, dude. What are we thinking here? I'm using SPD log quite a lot here though. Let me think. I mean, what they could have done really is like something like If it's not defined, SPD log FMT external. Then if we can define it, I guess. I don't know why they haven't done that, to be honest. But this is what it should have been, because now if we build this, you know, it's not going to give us that same error, at least. You know, in fact, the first error we get now is, oh look, there you go, it's a different one. But I don't understand why they didn't put the guards in here in the first place. But this shouldn't be included more than once though. It not be defined more than once anywhere. Because of this guard here, it says, you know, if it's already included, do not include it again. Which means this code here will never be running twice. Oh. Interesting. Anyway, let's leave that there for now, and we'll think about what we just did. Right, next error. The following one is treated as an error. The signed, unsigned mismatch. Okay, so this is, what is this? This is an unsigned long, and this is a signed long. Okay, so well, there you go. Best thing we can do, build it. Status flag, unreferenced formal parameter. Again, since we're not referencing it, the best thing we can do for now is just to comment it out like this and build it. And the time info as well, obviously it's not. Build it again, and here we go. And the following error is treated as an error. The following one is treated as an error, and we've got instance unreferred formal parameter. So we can simply remove it from here, I guess. Unless it needs a name, right? Nope, it does work. Right, so let's have a look at this next error. Not using this package because we pass enable with false. Cool. And problems anyway, so the following error is treated. So argument conversion from const float to const unsigned int, possible loss of data. Okay, so number of samples is definitely float. Why is it a float? Do we need to have it as a float somewhere? On this code it doesn't look like we do. Yeah, what we can do here in this particular case is actually just static cast it, because we know we're doing a bad cast here. We definitely want to operate the maps in float mode though, not gonna lie. It should really be like this. MS is an integer, okay, cool. Yeah, we should operate this in a float mode and then just cast, oh, what did I do here? And just cast that result to float because we, oh sorry, it should have been, I guess, an integer. Let's keep it as int for now. What does the quality of it look like at the moment? Definitely want to operate the maps Okay, cool. Just making sure it doesn't look too bad. Let's look at the problems. So they're going down. I mean, we have the multiplier. It should really be this, right? Because it's let's just keep it as that. Argument conversion from columns flow to int possible loss of data. So time in milliseconds. Where's that defined in though? Flow time in milliseconds. Can it not be an integer for now? I mean, all the chrono functions only take integers anyway, right? When you set in the times. There you go, no problems have been detected, which means it did compile. So at least we got rid of most of the warnings, I guess. That's a good thing to do. Let's do one more bit of the general refactoring now. And then I might call it a night because it's getting quite late. I've got that note stuff here. Space Odyssey song itself, saying which notes will play for how long. Let's leave that here for now. Get note frequency. What does this do? This gets note ID and returns a optional float, which is the frequency, right? Okay, I kind of like this, so let's leave this as it is here. Create the square wave. How is this looking now? This is okay, I guess. Is it? Let's have a look. What are we doing here? Oh, we're actually creating the square wave here, right? Yeah. I mean, can we turn this into a stud, an STD algorithm kind of thing here? Because we're working out the number of samples that we need in total for this particular time, I guess. And then we work out the step. Yeah, we work out the steps here, and now I realize that because I turned this into an integer, it might be a little bit off in terms of the note itself. I mean, it shouldn't really matter. It shouldn't really matter at all if the sample rate is huge, really, which the error just becomes smaller and smaller, but which in our case is alright because it's 44.1k samples per second. But yeah, I mean, ignoring this for now, all we've got here is a value that's being tracking the current value, and this is going up every time, right, by the step. And we know how many waves do we need, right? It'll be this frequency. Essentially the frequency yes, the way I'm thinking here is like if we can create one oscillation of the wave. I'm not sure if I can get paint or something. So like this, we can just repeat this particular bit here, you know, many times after, you know what I mean? That might be quicker than doing value by value every time. Oh. And also, this is not even a square wave. What the hell am I doing? This is a... It's kind of like a sawtooth, right? So it's going up and going down. That's what it's doing, I think. Yeah, this is what it's doing. It's not really doing a square wave now that I think about it. So it goes from 1. Well, in fact, it goes from 0 first, all the way up to 1, and then it goes down. All to -1. Open to... Yeah, it's kind of doing this. Open to 1, which is kind of a sawtooth wave, right? Yeah, it's not really a square wave. Does it still work? Let's see. Does it still play the audio? It's out of interest, because we've done some work to it. Just want to make sure that still works. Can I pause the music for this? And we're at the mercy of Visual Studio Code deciding when to run the executable. There you go. Beautiful, beautiful. Now, if it turns into a proper square wave, like, what does it sound like? How do we do this? Well, the square wave, we do this number of samples there, and that number of samples there. Okay, cool. So we know how many samples we need per, full wave. So half of those will be at 1, and half of those will be at -1. That's what we're gonna do here. Yeah, let's actually forget about this bit here for now. We're gonna create one of those waves. Let me just think what the best way of doing that is. Because essentially we're going to repeat that many times. You see that it will be joined like that. So is there a function in the standard library that will repeat a vector many times in C++? See, I don't want to repeat the same value. I want to repeat a vector many times. We'll do n copies of a vector, if you see what I mean. Well, yeah, I mean, I could just put it into a vector in the first place and then just and then do a for loop where number of iterations will be the number of repetitions of my wave, right? That isn't too hard to figure out because it will be the frequency itself. But yeah, let's see. So, if we were to create the initial vector, one wave kind of, or one oscillation, let's just not even assign anything to it. One oscillation, they'll reserve, and how many do we have to reserve? Well, that is the number of samples that we would need for one particular oscillation. So what is that? What is that value? Yeah, so that is literally 44100.0 divided by the frequency. And again, we're going to just ugly static cast here because we want to operate this whole thing in float mode until we have to cast it to integer. May have to save this in a second. Yeah, let's save that actually here. So auto const, and then we've got the sample per oscillations or something. That'll be 44100.0f divided by the frequency. And then again here, we just need to static cast to be an integer or something that samples sample per second per oscillation. Or in fact, we can straight away start with that that constructor a vector that will make you n copies of one item, and that can be 1. And then for the other half, we double the vector, essentially adding the rest of the oscillations. If you see what I mean. We're composing all of this quite nicely. Yeah, let's do that. And this is going to be a value of 1.0 f. How many times? Sample oscillations divided by 2, really. That's what we want to do. And then the same thing for the minus or the negative. Positive. And that will be minus 0.0, minus 1.0. And then what we can do here is, I know it's beginning to get a little bit complicated. Now we can do that for loop, probably say, for int I 0, I is the number of waves that we need per second, which is just frequency when you think about it. We need this many waves per second to create that particular note. We're gonna increment I every time. And we'll probably need a SD vector flow here, fortunately. Which will be the whole wave, the whole sound. Put it that way. And if we want to be very efficient, not, in other words, not growing our vector all the time, we can just reserve it, and that will be the number of samples in total, which we already calculated up here, at least. And if be even safer, put like an extra 10 on it, or yeah, an extra 10 just to make sure it doesn't go over for now. And this is because we've been doing the calculations in float mode and then sort of truncating everything, so I haven't figured out yet, but this one may be smaller than the size of these ones here times 2. And all we need to do now is just do the whole sound dot insert at the back. We've got the beginning of positive and the end of positive here. And the same thing for the negative. Like, dude, what's going on here? Identifier back. It's the end, sorry. What am I doing? And then we've got a negative and negative here. Now this thing can go, basically. So the idea here is that I created, the number of necessary ones and necessary minus ones all in one go, in one buffer. And I'm simply just copying that buffer around, which will be, I'm not sure if it's quicker, doing one by one. But sounds like it could be something that we can essentially just benchmark at some point. Really, that would be the best thing to do. And let's compile it. Hopefully, we're gonna get no warnings. Oh, we did get a warning, so unused. Cool. We can remove that, no problem. And sound wave is also unused, right? Apart from reserve here. Let's build it again. Okay, cool, no problems. So let's run this and see what kind of sound we get now. Please work. It did not work. Did not work at all. And why is that? Let's see. When we create this, what do we return? Whole sound. What is whole sound? Yeah, sounds wrong. It's very wrong. So we insert at the end of whole sound, the beginning of oscillations. What's sample per oscillation? So when we have that, we have about 84-ish. Why is this only 2? Why is the capacity only 2? What's the SD vector? I'm trying to use the constructor way. It takes an element and a number of elements. So hopefully that's the one I picked. Ah, there you go. It's the wrong way around. Pause. So this is it, and 1.0f. And the same thing here. I always confuse this. That's why I was checking. So this is the count, and this is the actual value that's going to copy over and over again. Is it going to work? Don't know. Let's see. Still doesn't work. And the question is why. Let's find out. Okay, so the positive oscillations. We still have 2. Only 2 here. Ah, okay, I know exactly what's going on. This has been taken in as a initializer list, which is what we don't want. So it's taking those 2 elements as an initializer list, not the actual constructor that takes a count and a value. So yeah, this can happen quite a lot in C++, and it's quite annoying because you expect the curly braces to sort of work properly everywhere. And again, this is going to return me an error because it's a float and I'm trying to use an unsigned int here. So, okay. So if I static cast this to unsigned int, and the whole thing should just be fine. It built now, didn't it? So let's take a look again. Hopefully by this time things are going to work properly. But I'm not too sure anymore, you see. Okay, so whole song is here. Finally. Yeah, finally it's working. I did notice something at the end though. It's kind of like a glitch in the audio, but I'm gonna ignore that for now. And this sounds more like a square wave. Yeah, there was no glitch this time. Let's run again. Yeah, sounds much more like a square wave. At the end of the day, we didn't do any refactoring today. We just spotted things that were wrong in the code. But let's figure out what we can do in the future though. Like audio queue is on the boost here. So these are the things that we can maybe put at the very top. These are already in the anonymous namespace. What is this doing? Write to buffer. Is write to buffer being used? It is. It is being used, but why? Okay, yeah, so actually write to buffer, I guess. Queue ready test. Okay, so that is only used down here. Why is it up there? I like putting variables near where they're supposed to be used, to be honest. Okay, so right available, left available. We do need to look at this logic here, because I'm not entirely sure the logic will work all the time. There may be some cases where the loop keeps going forever, basically. And I need to really figure it out. Here's the final way for it to basically finish. Okay, I mean, maybe in the future we can take a look at the audio as well. The audio, let's remove that comment, we don't need it anymore. The stream callback. Okay, now we do need these definitions here. Because they have been used in a callback. Let me take a look at unique points of why delete it. May not be safe. I don't know what I did here. I don't know why I put this comment here. Why would this not be safe? Maybe unique point to avoid. Is that what it is? It is. It's unique point to avoid. Is unique point to avoid allowed? Am I doing some undefined behavior in this case? I don't know. Let's have a look. Is it possible to transfer ownership from a avoid star to a unique pointer? Hmm. Overview. In C++, point specific type primitive can be assigned to avoid star without any explicit typecast. Yes, you can. The avoid star can be typecasted back to a pointer of any type. So basically what I'm trying to do here is figure out where whether we can have a unique pointer avoid, because essentially we have a void star in our code, and that's not very good practice, but we do know in this particular case here what the deleter for this pointer is, the PA stream pointer. Like it's a function called PA stream destroyer, which will stop the stream and also close it. And as per the PortAudio library, this is in fact a void star. But I'm not sure if C++ has any guarantees on that pointer once you put it, not on guarantees, but any caveats if you're using a void star in a unique pointer. Essentially, that's what I want to find out, because I don't know. I'm gonna definitely read this because it's definitely an interesting read. But for now, I'm gonna turn off the stream, and thank you very much for watching me. If anyone's watching this in the future, I'm actually hoping to compile all of these videos that I've been live streaming for, and do a very nice start to finish 10-minute video where I talk over everything and explain the challenges that I had in this PortAudio project. And yeah, just as a spoiler as well, the future on what the future holds here for this project, I want to essentially implement a wave file reader, so an audio file reader, very simple essentially, that you basically just call the program and say read this WAV file. It will read it and then play with PortAudio, and that's it. I'll be quite accomplished if I do that, actually, because I have no idea how, well, I have very little knowledge on audio frameworks, so I'm trying to learn how these frameworks essentially work and how it wraps around things like Wasapi, ALSA, or even PortAudio. Sorry, PulseAudio, which is a very kind of, well, a little bit more high level than ALSA, right? But yeah, this is what PortAudio does. It just wraps around all of that. So learning PortAudio would be basically useful for going into audio programming in the future. So that's what I'm doing here. And thanks for watching this, and yeah, have a good night. I'll see you in a bit.